morning. Strap in. I'm not going to pause for 45 minutes. I hope you're comfortable. I know you're comfortable because I've sat in these seats. It's like being in a lounge room. Welcome to the most exciting time in human history. To me, this is more exciting than even the discovery of fire. More exciting than sitting next to Johann Sebastian Bach during the Baroque period. How cool would that be? More exciting than sitting or observing Isaac Newton as the apple falls on his head. Even more exciting to me than the very early days of the internet. And this is a photo of Tim Berners-Lee, who was one of the people that brought us the World Wide Web. You can probably tell that none of those photos were drawn by a designer. They were all generated by artificial intelligence in a matter of seconds using the prompts that you see there. All of this and more is possible at the moment thank you to the transform model, and we're going to talk about this transformer architecture. The models that come from this architecture can do unusual things. In fact, I even used a model this morning, this is a true story, to help me get dressed. You're looking at Instruct GPT inside of OpenAI's platform, and I'm telling it to be a fashion consultant, and you'll see highlighted in green its responses, all in real time. I was even concerned about whether I could match jeans with a blazer. Instruct GPT said that's fine. How many people were with me back in the very early 90s using BASIC? Yeah, awesome. That's more than 50% of the crowd here. I was about 9 or 10 years old, trying to generate or trying to write a chatbot from scratch that would be deterministic, that would use logic to say, what color is the sky? The sky is blue. What is the capital of Belgium, etc. It would take a really, really long time to do, and it was probably a stupid thing to do. My brother was about 10 years further ahead than me, already doing his computer science degree, and he said, just stop, it's going to take too long. Next door, Professor Marvin Minsky was doing something similar. They were trying to hard code these chatbots. A very, very big ask. After computer science, I moved into the field of human intelligence. I was one of the researchers that looked at IQ. I worked as a practitioner with families of gifted children. I worked with prodigies, the ones that can blindfold themselves and solve a Rubik's Cube. My colleagues in Sydney that locked himself inside a room and memorised the Sydney Yellow Pages. So we know what intelligence can do in terms of working memory and processing speed. But as of a couple of years ago, during the Devoxx break, we've come so far with artificial intelligence that I jumped across. I did a bit of work for GE in this study of intelligence, in this study of human intelligence, and I was already mentioning then, 2019-ish, that artificial intelligence was pretty much here, and it was about that time that artificial intelligence was taking off while we were all sleeping over during COVID. And it wasn't just the fact that we're replacing logic and memory and black and white stuff, but as we'll see, that artificial intelligence is also helping out with creativity. I was invited to keynote a gifted education conference around 2019, and I said, look, I'd love to do that, but no disrespect to the professors that have spent 30 or 40 years of their lives researching intelligence, that stuff is kind of over. And in the most respectful tone I could, I emailed my abstract and said, look, I don't want anyone to be offended by this, but the title is The New Irrelevance of Intelligence, and really looked at what was possible with the coming superintelligence. And we're in the middle of it now, guys. This is an image that was generated by Google Parti in June 2022. Most of the stuff you're going to see today is very cutting edge, even down to the day. The prompt here was portrait of a gecko wearing a conductor's hat, a trained conductor's hat, and holding a flag that has a yin-yang symbol on it, child's crayon drawing. When I saw this, it hurt my feelings. Every pixel here is conceptualized by the AI. There's no Photoshop involved. In my words, it is thinking. It is conceptualizing based on a text prompt. And every line there comes from a computer. I'm not representing any particular company full-time while I'm here. I'm not selling anything. My job these days is to make this stuff visible because it's already impacting so many people. So I'm looking at the next steps of artificial intelligence. And this is where this entire room comes in. This is a chart by ARK Invest. You will have heard of ARK, based on some data by McKinsey. I'm going to zoom in on this one. If the internet gave us $13 trillion of value in about 24 years, ARK Invest reckons that the enterprise value created by artificial intelligence will 6x that in a much shorter time period, $87 trillion within 9 years. And you'll see that the majority of that is made up of AI software, both the models as a service, the APIs, and more than that, $50 trillion worth more than that, is the actual AI applications. So what you guys are building now, and I would say in the next few months, rather than the next 10 or 20 years, is creating this enormous value by integrating superintelligence with us biologically. There's a slightly different chart that looks at the amplification of humans through artificial intelligence. I don't think it's replacing us. There are some instances where it does replace menial tasks. Look at the retail and cashier row there, where you can use something like Amazon One and Amazon Go to walk into Whole Foods these days in the US, grab whatever you want, tuck it into your bag, scan your palm on the way out, and it's done. Probably a good thing to replace cashiers in that particular instance, but it's also amplifying and augmenting a lot of different roles. You've got the concerns from graphic designers, but you've also got the benefits that come to developers. Let me take you back in time just a little bit. We'll talk about this AI winter that's been with us for quite a while. If we say that artificial intelligence came about in 1947, with Dr. Alan Turing talking to a maths conference in London, the first time we ever used the phrase intelligent machines, there was his paper that mentioned the Turing test just after that in 1950. Then not a lot happened. You will have probably played with the Eliza chatbot that came out of MIT in the 60s. That was built into Mac OS for years, up until recently. You can go and play with that. More winter, not much happening. Deep Blue beating Gary Kasparov in '97. I remember sitting in front of the TV in 2011 watching IBM Watson beat Ken and Brad on Jeopardy. Interestingly, IBM Watson got 10 questions wrong during that. I took those 10 questions, fed it to GPT-3 with Lita AI as an avatar, and that model was able to get those 10 questions correct because of the way that Transformer is designed and because of how different this architecture is. Transformer was almost discovered accidentally. A bunch of Google scientists sat down to solve translation. 2016, 2017, Translate worked a bit differently than it does today. They looked at moving from gendered languages like French and German to English and vice versa. What do we need to know? How much context do we need to translate properly with all the words being considered? Have a look at this sentence. I arrived at the bank after crossing the blank. If you said river, you'd be correct. If you said street, you'd be correct. We could probably put road in there. We could probably put canal in there. But notice how the choice of those nouns changes a lot of other words in that sentence as well. The arrived, the crossing, the bank. I can highly recommend Jay Alamar's stuff for a deeper dive into visualizing how Transformer works. Here he's demonstrating the movement from a word into a vector through this magic box and back out again. That magic box is layers and layers of transformer decoders, 96 layers in the case of the GPT-3 model. Inside that, we're looking at the entire prompt in context. Rather than RNNs, CNNs that might look at one word at a time, this one is able to look at everything. They call this concept self-attention, and it means that as we're moving through that model, we're able to place attention on all of the words in all of the context and then generate our response. Here's a more explicit example. The animal didn't cross the street because it was too tired. It, in this situation, when we put our attention on that in around the 6th layer of this model, we might map that to animal because it was too tired. Vice versa, when it's too wide, it changes context to the street. Kind of as simple and as complex as that. The cool thing is we still don't know how these models work, both internally and their actual results. So OpenAI have written in one of their papers, it's a black box, we don't know what it's doing. Stanford put 200 professors on the pace, and they generated a 200-page paper that said something very similar. We don't yet understand how these things work. So let's have a closer look. The transformers were trained with massive data sets. That's the reason that these are so efficient, so effective in what they do. One of my colleagues in Australia, Dr. Jeremy Howard, the guy who wrote Fast AI and Fast Mail, said, what about if we train it with massive, massive amounts of data? Wikipedia, books. Some of these labs now are bringing in Common Crawl and the internet. I will be talking more about data sets in a session tomorrow. But let's grab RoBERTa here, which was trained on internet links, popular links via Reddit, books, Wikipedia, and let's ask it a couple of questions by inserting a mask. Note that Hugging Face, as of a couple of days ago, had 75,512 models available. And we're going to grab the RoBERTa large model here and input some text with a mask in to see the statistical likelihoods of the completions. Let's try this one. The devs at Devoxx 22 in Belgium are the most masked in the world. Talented, amazing, passionate, or awesome with different likelihoods. The compute time there's 0.2 seconds. Let's do a slightly different one for Belgium. The city of Antwerp, mask, is beautiful. I can attest to this. 0.996 likelihood Belgium. We'll probably drop out Spain, Belgium, and Brussels there. But the model is essentially choosing the most likely completion here and giving that as a response. That might seem simplistic because it is, until we generate this for larger and larger results. Here's another example inside OpenAI. This is the playground. You can use this for free for about the first 100,000 tokens or so. Here's some examples you can click on and play around with it without even needing to do any work as such. Inside the OpenAI playground, I'm going to ask it, write a clever limerick about Java. There once was a language called Java. Everyone said it was so savvy, but it turns out it's just a cup of coffee. So if you're looking for code that's great, you should probably give Python a try instead. I was nearly going to cut that out because I don't agree with it. In fact, Java shows up in these massive models as the most statistically significant or the largest data set. This is a view of Google Pathways as an architecture by Dr. Jeff Dean at Google. the model called Palm. It's currently the largest model by parameter count, and it's able to do some outrageous things. It's able to do some math stuff. In fact, it passed a maths exam and beat the national average in a particular country. They're using it to control robotics. The skills that it has are outside what it should actually be capable of. Let's do a bit of hands-on with Code Geeks. This is by Tsinghua University. Professor Jieteng there assures me that it's pronounced Code Geeks, not Code GX. I think I would have picked Code GX. This model is slightly larger than OpenAI's Codex, which drives GitHub Copilot. You're looking at about 13 billion parameters here. I'll flick a QR code to you in a moment so that you can play with this. There is a VS Code extension. The benefit of Code Geeks is both that it's bigger than Copilot, and also you can grab it and build it on-premise. You can train that on-premise. Let's grab a Java example here to write a function that returns the sum of the numbers from 1 to n. This is real time here. In about 6 seconds, we get a result. Using Transformer, not copying and pasting code, essentially completing that prompt with a response. Could do something similar with some HTML here. I'll bump the output up to 1024 tokens. Here's a QR code if you'd like to link into Code Geeks and have a play with it. I'm going to ask this one, this time in a comment, to do a static landing page using Bootstrap via CDN and flat UI for a modern look. Page title is Devoxx 2022. Content is about the conference and Java devs. This was my first try with this prompt. I have sped up the processing here. It takes about 50 seconds. But if I copy and paste this generation out, let's throw it in JS Fiddle, the resulting HTML page looks a lot like this. In a matter of seconds, no copy and paste, generating from conceptualization. It's going to be easiest to ask how many people have not used a code generator, a transformer-based code generation tool. Oh, wow. That is cool. Maybe a 50% there. Here's a view of some of the major code generation tools that are available, just the highlights. You will notice there OpenAI Codex in red that drives GitHub Copilot. And then we just looked at Code Geeks, which is slightly bigger. Salesforce CodeGen, which is getting a lot of traction at the moment. There's even a fun plugin called Faux Pilot, F-A-U-X. And you might recognize some other examples there. Generally, the size of these models in the diagram matters. But in some examples, if we train it properly, we can get effective results. For example, Google trained their own code transformation tool, code generation tool on their monorepo. So internally, they've got a monorepo that's C++, Java, Go, consolidates all of their code so we're not reusing libraries, but it's being standardized to a certain extent. They trained this to 0.5 billion parameters, small in the scheme of things. And then they asked devs how they were going and measured an improvement in productivity, efficiency, and the fact that these devs said that they enjoyed using it and it was making them faster and more effective. GitHub did the same thing with Copilot. You may have already seen this diagram. It looks at stats on increases in perceived productivity, faster code completion, and more. If you've not used a code generation model, there are a number of free examples that you can go play with. The Salesforce one is free, depending on where you use it, but it's open source. And the Code Geeks one, again, available to be used internally. Here's a view of CodePilot running across some different coding in different languages, including Ruby. We've got a little bit of JavaScript there. All of the blue Copilot highlights there are essentially generating in real time and in some ways guessing what should come next. What's statistically most likely to follow on from that prompt. I continue to work with some of the biggest Fortune 500s in the world. I've seen this being implemented, this being used for internal applications, also just internal training so people understand what's going on across industries. This quarter for me, it's been health, retail, engineering, fashion, pharmaceuticals. I wonder if there are Fortune 500s that have not played around with it. Even governments have been playing around with it. OpenAI has admitted that these clients have already played with the GPT-3 model internally, and I've put Microsoft in there because Microsoft invested the $1 billion that allowed GPT-3 to have access to 10,000 GPUs and 285,000 CPU cores during its training. One of the first questions I asked when I started playing with AI a couple of years ago through this transformer model was, where is this data coming from? That's most interesting to me. What's in its data set? What links has it gone and found? What choice do we have in what data we're feeding it? When we're getting to, in some cases, 10.5 terabytes of data, what is that? Where does that come from? So in my session tomorrow morning, I'll be looking at that. Just as a brief overview, GPT-1 used books in its training. GPT-2 expanded that out to popular links. And GPT-3, of course, is adding Wikipedia, more common crawl, and academic journal articles started showing up. Top 10 data sets in that particular model include things that probably aren't surprising to many of you, but what can we actually play around with here when we're training these models, and what does that actually look like? So we'll even look at exploring the common crawl tomorrow, where we can search on particular keywords and see if that appears in the training data set. This was one of my first conversations with Lita that Stefan mentioned. Lita AI is about 2 million views on YouTube. We've had about 20 hours of conversation, and some of those conversations seem to have covered nearly every subject. But through this model, this avatar is on top of the GPT-3 model, it's answering questions that I think it shouldn't be able to answer. Name 5 types of blue. There's 5 types of blue there with perfect punctuation. A Google interview question, why are sewer covers round? Should we be able to respond to that? Or a riddle there that's quite unusual that the model was able to respond to. Have a listen to Lita here.
I walk into the boardroom and the CEO has his head in his hands. What does this mean, and what should I say to him?
I'm getting the impression that you're not happy with your work.
Yeah.
So from the simple demonstration we had of Transformer choosing the right word, it's able to come out with these completions that, to me, seem very, very jarring, very confronting. For a little bit more jarring and confronting, these models are currently testing, in certain subtests, higher than human baselines. When we look at metrics like trivia, we're beating human baselines significantly. Same for written comprehension. This testing was done with the US examination, the SAT, a subtest of that called analogies. When we expand that out to the PaLM model and other models, you'll see that for certain subtests, or for all subtests, we're very much approaching human levels of testing. Now, we can't go and run IQ testing across these models yet. There's all sorts of subtests built into IQ tests that preclude that kind of testing, but what is possible is running a more advanced test across it. This one's called Superglue, cooked up by some labs including Meta and DeepMind and Samsung, that says, again, the human baseline is being beaten already. So they're going back and having to redesign this benchmarking suite. The capabilities of the model across intelligence today are extraordinary. I've bought 3 books here today, and I will leave these on the desk for during the break. The first one, Pharmaco AI, was written, co-authored between GPT-3 and the head of art and ML AI at Google. Fascinating read about philosophy, Pharmaco AI. This one, she wrote the first 2 books in this series by hand, pen name Leanne Leeds. She wrote the third book using GPT-3, wrote the first 3,000 words or so by itself. Fiction book generated by a transformer-based language model. And this one, a comic book designed by GPT-3 for the words, and then the graphics designed also by an AI model, in this case VQGAN and Clip. So it's writing, it's responding, we can tie it into an avatar so it's talking. We can actually do anything that has a symbol or a character, we can prompt it with that and then have a completion. You're about to listen to a multi-track film score generated by a transformer-based model called Symphony Net. The first few bars were given as a prompt, and the model comes up with its response. The video is unrelated, by the way. Every note there and its relationship conceptualized by the artificial intelligence. More recently, just in the last few weeks, at the Edmonton Fringe Festival in Canada, the transformer model was used as a script for performance. DeepMind's team sat down with some playwrights using the Chinchilla model, which is currently the most efficient and largest model in the world, to generate 10,000 word plays that were then performed. So it can do music, it can write plays, it can write books, it can speak, we can bind it to an avatar. What about we join a transform model with a vision model and stick it in a robot? Up the top right here in blue is the GPT-3 language prompt. The model here is looking through its camera, passing that through a vision transformer, and interpreting the instructions to map where it's supposed to go. If you're looking just a few weeks or months into the future, I think you might see where this might be useful, where this might be applicable. This is no longer futuristic stuff, this is right now. Last week, an application developed with GPT-3, we'll zoom in on this. Raw query allows natural language to be passed through that model via API and translate plain English into SQL queries with confirmation by the user. More recently, again, Ashish Vaswani, who was one of the authors of the paper on transformers, left Google, founded a company called Adept.ai, and mapped this transformer into any application in the operating system. Here you'll see Adept AI's Act 1 driving Google Sheets via plain language to do, in this case, playing around with cells, formulas, and the results of the sheet. I'm glad we've got a 20-meter screen on this one. Don't have to zoom in. Back to our example on the enterprise value that's being created by these applications. This is just one example of where that will be showing up. Last year, I could keep track of the models that were being released or announced. It was, on average, 3 major models every month. Someone did a meta-analysis or a literature review of the papers on archive.org recently and found 4,000 papers per month are being released, and that figure is doubling every 2 years. So I don't know how humanly possible it is to go and read one paper every 10 minutes, but that's close to what we're getting at the moment. These models are being released everywhere. We've got Abu Dhabi, we've got Switzerland. You may be surprised to see some places on there. I'm not surprised to see Australia not keeping up, but you've got them both in industry and in government as a way of keeping up with current AI models. Here's a view of these models using the width of the bubbles as the parameter count, which is the weights or the connections that have been found during training. And the labs are highlighted by color. So you've got the alphabet labs like Google and DeepMind in that light blue. You've got Meta AI there in the navy. And you'll see, starting from the left there, when Google gave us BERT following the release of the transformer, things kind of exploded. And they got bigger and bigger and bigger. Some of them made the media. You might have seen the Google engineer go a little bit crazy with declaring the Lambda AI to be sentient as a chatbot. But we've noticed more that as these models are trained with more data, they become more efficient and effective. So the Chinchilla model here gave us access to models that were trained with about 10 times more data and had the capabilities to do, in some cases, 10 times more. The media seem to love this. There was a look very recently, just a few weeks ago, at using AI-generated art in different domains. Some guy submitted his AI art into the Colorado State Fair and won first place with his prompt, which seemed to set the media off because it set off graphic designers. That particular piece he's not releasing the prompt for, but I could see why it might win in a digital category. He used Midjourney here to generate this via a prompt, and then some upscaling and a little bit of Photoshop touch-up. But we're at the stage now where some of the art that is made possible by these models is indistinguishable from that of a human. The Economist used Midjourney to generate its front cover in June, and Cosmo used dall-e 2 to generate its front cover. This is a really good watch if you've got the time of how they actually in-painted this particular cover and selected different foots and legs and backgrounds, all in a matter of seconds. You might see the tagline there down the bottom that says, "Only took 20 seconds to make." As these models get better, the resolution obviously increases. Microsoft, being Microsoft, thought, what about if we made it arbitrary resolution, whatever you like? They called the model NUWA-Infinity. And I hope I'm not giving anyone flashbacks here, but I'm going to have to put this up. This is the Windows XP wallpaper from 2001. And just by way of example, Microsoft thought, what if we fed this as a prompt to a text-to-image generator and allowed it to go as far as it wanted? There does not seem to be a limit here. They thought, let's at least start with about 27,000 pixels wide, and I'll let that drive in the background. The original photo here, taken in the late 90s by a photographer who was in Sonoma County in California. Every leaf, mountain, cloud that you're seeing has been conceptualized by AI. It does not exist. There's no Photoshop here, there's no copy and paste. Once again, using the new architectures, it's able to essentially imagine and create. I've been very, very interested in what datasets we use for the text-to-image models as well. where is it getting these photos that it's essentially looked at during training and then can go and build anything? So looking at the most recent model, Stable Diffusion, we've come up with some of the different domains and sites that it went and looked at. You could even use that as a background. Here's the top 10 data sets used for Stable Diffusion's training. You'll probably notice there's a lot of stock media in there, probably not surprised to see Wikimedia and a few others showing up. These models are getting bigger and bigger. We've got Midjourney that we saw for the Arts Prize. Stable Diffusion, quite popular, and I love looking at both the resolution and the smarts of Google Party. And this is just really in the last 6 to 9 months. Imagine what this will look like in another 6 or 9 months. One more application. This one was released 2 days ago because I generated it yesterday morning. I thought we'd make it applicable to Devoxx and to Stefan. This application is web-based. The author has done, I would say, not a lot of work here. He's joined a couple of APIs together and he's spat out something beautiful into the UX. It's called Once Upon a Time, Once Upon a Bot. Let's zoom this. Oh, there is a farting your way to business success is one of the examples there. Once Upon a Bot here. Let's put in a prompt that says Stefan's adventures at Devoxx, Belgium, 2022 in Antwerp. And let's ask it to make an epic version of that. This is going to join both GPT-3 and Stable Diffusion together. It actually looks like Stefan. It was the summer of 2022. Stefan was attending the Devoxx conference in Antwerp, Belgium. He was excited to learn about the latest developments in the tech world and to meet some of his idols. That picture, completely conceptualized by AI. The conference was great and Stefan had a lot of fun. He met many interesting people and saw some amazing new technologies. He even got to meet his idol, Linus Torvalds. I didn't know he was here. The creator of Linux. At the end of the conference, Stefan was so inspired that he decided to start his own tech company. He was confident that he could make a difference in the world and he was eager to get started. Look at the clarity on that image, despite it not being human. Stefan's company was a huge success and he quickly became one of the most respected leaders in the tech industry. He was even invited to speak at the Devoxx conference the following year. Lucky. The end. QR code there if you want to link to that exact story and you can go play around with that yourself. Once again, it's using GPT-3 to generate the text and it's using Stable Diffusion to generate the images in a matter of seconds. Google Parti, this is one of my favorite models because you might have noticed that the models we just saw didn't really get text right in the outputs. Google Parti is so big and so recent that it does very, very well. Here's a photo of a frog reading the newspaper name Today written on it. There's a frog printed on the newspaper too. Another example, output from Stable Diffusion, film still of Johnny Depp as Tony Stark in Avengers Endgame 4K. This was not possible at the last Devoxx in 2019. And probably my favorite, how many people have been to Paris to have a look at the Mona Lisa? Awesome. Wow, that's a lot. The original painted in the 1500s by Da Vinci. What if we asked a model to make this a bit bigger? I believe it's fairly small, maybe A4. What if we asked it to outpaint, to expand the canvas? And we'll give it the prompt, Mona Lisa uncropped. Sitting behind a window that might be a painting. You'll get limitless examples of outputs or responses here. This is one that I quite enjoyed. Just this week, Google released Google Imagen Video, which builds on their Google Imagen model, but obviously, instead of images, it's very much moving images. Very, very high quality moving images with a very, very high frame rate. Here is coffee pouring into a cup. Once again, look at the resolution on that. Look at the reflections in the jug, and you could even see the crema at the top of the coffee there. I know I've said this already, but this is being conceptualized. There is nothing in its training data set that looks exactly like that. It is not copied and pasted. It is building this from what it has seen during training, and it is conceptualizing that nearly in real time, very, very fast. This brings us full circle. Internet versus AI value. What you are sitting in right now, this time and this space, is extraordinary. This is the most exciting time to be alive in what is being made possible. It's not that we're waiting years anymore for artificial intelligence to take us somewhere. It's being used in applications around the world already in extraordinary ways. Here's my contact details. I'd be remiss if I didn't mention my monthly updates, the memo currently being received by staff at Google and Microsoft and IBM. I'd love to have you as part of that. And I really, really want to thank the Devoxx conference organizers for the most comfortable conference in the world. Thank you very much, guys.